some of the most important people in the Bittensor ecosystem in my estimation. Cameron, I think you've been in the Discord here since 2021, no?
Yeah. Yes, I have.
And we hired Cameron as a intern, a very successful intern. We paid him like an illegally small wage for an illegally long period of time. He has fixed the chain and saved all of us from being destitute a number of times. Cameron just about runs the Nucleus team at OpenTensor, even though he's not at OpenTensor. He's maintained the Bittensor API, the SDK, front ends. You've basically been everywhere from start to finish, really, as one of OpenTensor's core employees for years. When OpenTensor was beginning to be decentralized, when we were starting this process about a year and a half ago, everybody, we're going to try to break apart OpenTensor into a set of different teams that that can sustain themselves. So, your jobs are quote unquote like under threat, but don't worry, we're gonna figure out how to split you off in a safe way. And really, one of the teams that came to the rescue here that actually funded the developers that maintain the Bittensor SDK, our infrastructure and contribute to the Nucleus team, super important things that are very expensive and very critical for maintaining Bittensor. A lot of that was taken on by Latent, Joseph Jackson on the stage. So anyways, it's a pleasure to have these two characters. We're going to go through all the drama, but I think that the headline from me here is that these are two individuals, and not to not mention Abe as well, who Abe has been around for a while as well and working with the SDK, and you guys are going to give a lot of attention to that. But these are characters that actually have really contributed to Bittensor altruistically, and a round of applause for them already before we get to see the presentation, which we can see. So yeah, thanks, Joseph, Abe, and Cameron, as well as Kara for emceeing with me. Let's get to it.
Great to be here. Thank you.
Okay, you're muted, JJ.
Sorry about that. Testing 1, 2, 3. All good?
Yeah, you're good.
Nice. Yeah, thank you, Jake. I'm the newcomer. I have not been involved since the 2021 ZERP era, but I definitely tweet a lot. Hopefully that's worth something. And it's an honor to be here. Thank you for inviting us, Jake. And yeah, we're servants of the mission of Bittensor. I like to say the Latent Holdings mission is the Bittensor mission. There's no difference. And we've been around for a grand total of around 9 months. We got started in November, October last year, incorporated and started building the team. Huge gratitude to you, Jake, for trusting us with taking over a lot of the core infrastructure and tool chain, CLI, SDK, and API server, and a lot of the core stuff. Obviously, Voon has been really immeasurably valuable for the protocol and the network, and he's been just a privilege to work with. One of the most talented people I've worked with in my career. So I'd love to go over kind of what we've done a bit as Latent Holdings, and then pass it over to Abe, who leads TaoHash, and kind of get to the core nitty gritty of things. But just to kind of cover what we've done, Latent is doing a variety of things. A lot of what we do is focus on open source and making Bittensor easily understandable, accessible, discoverable by people. So one of the things we've contributed is Tao app, which we think is kind of a different take on an Explorer analytics experience. I think a lot of people use Tao app. Obviously, we're the folks behind TaoHash, which we're going to focus on today. And additionally, we brought on Maciej Kula, based in Germany, and he's the founder of Learn Bittensor. Learn Bittensor is focused on really demystifying and simplifying the kind of understanding of the Bittensor protocol and what it represents and what it means for people. Mache is also really heavily involved in kind of responding instantaneously to people in Discord and socials on questions they have and things they're curious about the core primitives of the protocol. And he's kind of colloquially known as the bot of the Bittensor community. Learn Bittensor also produces a lot of research pieces. So on the open source side, like I was mentioning, Latent maintains a lot of the core pieces of open source kind of primitives and tooling for Bittensor. Obviously, the SDK, the CLI, async substrate, Bittensor wallet, decode, as well as DRAND, the DRAND client. So a bunch of core infrastructure. I would venture to say that we're the #1 open source contributors to Bittensor outside of the foundation, which we're really proud of and continuing to invest in and actually increase and deepen our investments in. We also are really privileged to maintain the Bittensor developer documentation, which is kind of the first experience for people that want to build subnets and understand how to program against the Bittensor primitives. And we do run validator and chain nodes, light nodes for Subtensor at that URL. Additionally, we've done things like build a layer 0 integration and sort of a bridge, making it easy for folks to build these kind of wrapping and extensibility tools for Tao to provide easier liquidity on ramps and integrations there. So just some highlights on the open source side of things. I think this is just in the last 9 months. Latent has produced over 100 releases for Bittensor core, close to 4,000 code commits, and close to 1,000 pull requests, 173,000 lines of code changed. Actually, 6 months. That's pretty crazy. I have to give a huge shout out to Ben, Roman, Abe, Ibrahim, and Cameron, aka Voon, on the team, who are sort of like predominantly behind those contributions. It's a really massive effort driven by just really 4 people. I personally have a grand total of probably 0 open source contributions to Bittensor, other than my evangelizations. But yeah, we're really proud of what Cameron and Abe and Roman and Ben have contributed. Obviously, Clement, Xavier, Dara, Michael, Mache, Yasmin are really awesome. But we're a really small team, and just mission driven around simplifying the understanding of Bittensor, increasing the standardization, the stability of the tooling, and making it easy for people to understand and sort of navigate and explore the subnet ecosystem. So yeah, with that, I guess I'll pass it over to Abe.
Speaking of subnets, TaoHash is subnet 14. Some of you might know that. And for those who don't know, what is TaoHash? It's a category-defining subnet operating a Bitcoin mining pool that's openly owned, has open access, and incentivizes miners with alpha. We offer wide support to miners, which increases the participation to the many, not the few. And why? Why TaoHash? 56.8% of the Bitcoin network hash rate is controlled by just 3 pools. There's Foundry, there's Ant Pool, there's via BTC. There's a couple of the big ones. But this is a big problem. And it's not good for the Bitcoin network. It's not good for crypto in general. So we'd like to solve that. Here's how TaoHash works. Miners send hash rate to TaoHash's pool. The pool sends it to the Bitcoin network. Then the network rewards us in Bitcoin. We pass these along to the miners, and the pool fee goes to the holders of the alpha. The miner performance is logged using the pool by the validators, and the validators track it and set weights onto the chain on the Bittensor network. Bittensor runs consensus, and new alpha is emitted. it goes to the miners for their work, and it goes to the validators for their efforts. So, miners pool hash rate and get paid in alpha. Mined Bitcoin is sent to the miners based on their shares, and the pool fee is kept by the subnet. The pool fee is given to the holders, returning them value on their stake. And also on our roadmap is a hash rate market. Hash rate will be sold by a smart contract and sent to the highest bidder. This monetizes the hash rate immediately and at a premium. TaoHash is also scalable. Using this simple equation, the current alpha price and the hash price of Bitcoin, we can calculate a theoretical maximum hash rate that TaoHash can incentivize. This is the maximum hash rate that the subnet can support via incentivization, and currently it sits around 72 exahash, assuming a $7 alpha price and roughly $57 hash price for Bitcoin. This is a comparison of the supported hash rate versus the current Bitcoin network hash rate. At the current price, we're around 7% of the current network hash rate, and this will scale linearly. You may be asking, why should I mine on TaoHash? We have the lowest pool fee in the market at around 2%, and we expect to lower it over time. We have lightning payouts with low thresholds, and they're frequent, sometimes daily. They have incredibly low fees. We also serve external miners. These are Bitcoin miners that are not connected to Bittensor, who will benefit from the lower pool fees. We're transparent about our metrics, about our accounting, and about our code. All our code is fully open source and auditable. We offer open source to miners and alpha holders. We also have open ownership, including decentralized governance led by the holders, on-chain voting, and again, the code is open source. You can contribute to it. You can see what's happening. We're permissionless. There's no sign up. You can get straight to mining immediately. Everything's on-chain. Some recent updates. We've been working hard over the last month to revamp the project. There are a few key changes we've made, and we'll go over why after. We've updated the incentive mechanism. We no longer rely on validators to return value to the subnet. Instead, we return the Bitcoin directly to the miners directly. This method is also favored by typical Bitcoin miners, which will help us attract more of them. We've added lightning payouts to attract smaller miners and reduce costs on fees. We've also upgraded our pool infrastructure to be more scalable, add broad support for hardware and firmware, and also NiceHash and mining rig rentals, and support custom mining setups. There are a few problems with the older design, so there's a lot of reasons why we moved away from it. The first one is scalability. The hash rate was capped artificially by the subnet price. So if you recall that equation I shared earlier, if we were giving out all of the value of the hash rate as alpha, there's only a certain amount we can ever incentivize, which means we were way lower than the 73 exahash that the maximum is at right now. And that also means that price movements had immediate impact to the hash rate, which can possibly create a downward spiral. We're much more tolerant to that now. There was also the problem of trust. We trusted validators way too much to return value. We've removed trust where possible, and we would become further trustless over time. There's the problem of buybacks. Buybacks return value to stakers unevenly. This allows some to benefit only themselves rather than all of the holders. Lastly is currency risk. We eliminated the problem of currency risk, where if the Tao to Bitcoin conversion drops, the subnet would be impacted. And right now, it won't see much of an impact from that because we don't rely on it being returned fully. And now for the future of TaoHash. Coming around end of Q3, which is this quarter, we're hoping to distribute some of the Bitcoin pool fee to the holders. It'll likely operate from a claim system using on-chain commitments. And we will replace this in the future with a smart contract, so we remove the trust of ourselves in the system, which is very important. Holders may optionally receive Tao, which would offer flexibility for those not wanting Bitcoin. We're also developing a smart contract to custody the mined Bitcoin. This will remove trust to us as subnet operators from the system. It makes miner payouts more verifiable, and it will make distribution to holders fully trustless. We'll also be developing an EVM-based hash rate marketplace. The market will sell hash rate trustlessly to the highest bidder over the EVM. Purchaser funds will be prepaid and sent quickly to the subnet for distribution. It'll fund miner payouts faster and at a premium, and also gives holders a higher premium on the hash rate that they're incentivizing. The market will be directed by the holders. Holders can dictate a floor price at which we will only mine to the subnet pool, and otherwise we will sell it to the highest bidder. We will also make decisions about accepted currencies and pricing oracles, etc. But that is to be seen. It's still in the design phase. We will also be decentralizing the pool infrastructure. That way it's not just hosted by one organization. We want all the infrastructure to be fault tolerant, to be trustless, and to be distributed. Likely, validators will end up hosting endpoints, but we are still in the design phase, so again, this is yet to be known. Does anyone have any questions? I may have gone through that pretty fast.
How can I invest, Boone? The tough comment. You guys know. So, okay. When TaoHash first hit the scene, it was quite a splash, right? It's actually been sort of like a 4-month splash. Let's go through like the story of TaoHash. Like, first of all, where is the drama? Why was there drama? Like, what was the original design? What did we learn about that? Because I mean, I can tell the story, but I think you guys should tell the story.
Yes. So the original design was supposed to be very simple, right? It's similar to a couple other subnets that are currently existing, which might show you problems. But anyway, those subnets and the old version of TaoHash would try to encapsulate the entire value of the production of hash rate, like the entire value of that hash rate, within the amount that you're emitting to miners. And I'll go back to the equation that I had so we can see it easier. So this is part of the scale issue, right? This is one of the issues. So if you take the price and you multiply it by the maximum miner emission per block, which is 0.41 alpha, you can't emit more than that ever. You can emit less than that through burning, but you can never emit more. There's only 7,200 blocks per day. And if we assume that we're giving 100% instead of this 0.5%, and you divide it by the hash price, you get so much less than 72 exahash. You get a very small amount. And also now you have this cap, right? Which means, again, if you were to, I don't think I say it here, but yeah, if you were to lower the price, say somebody were to sell a lot, like a big holder, big miner, then suddenly the hash rate just dips, right? Because people are adjusting and they can't get rewarded more by your subnet. You can't just print more alpha than the current max, right? So you can't actually incentivize the current amount. It's not sustainable, right? There's also a problem with the validators. That was a big problem. So the validators, we were trusting them for some reason. Horrible design, looking back, but we were trusting them to return value to the subnet. This is actually, it's interesting because a lot of subnets kind of operate on this idea of the validators are gatekeeping the commodity because they have the stake weight. So since they're the stake weight, or at least the representatives of it, so they're the representatives of the stake weight, so miners listen to them, so they should gate it. So they should sell the commodity, right? And they should have access to it. So through doing that, they will then hopefully monetize it and then drive value back into the subnet because they want more of this bandwidth. They want more of this commodity. They want more access. And this is the same thinking I had for TaoHash is, well, if they're getting Bitcoin, right, then they can sell this Bitcoin and then they can use that money to buy more alpha should they want more Bitcoin. And then they should keep doing that and we should just have a return of Bitcoin coming to the subnet. But instead what happened is a lot of validators just kept the Bitcoin. They sold the Bitcoin. They funded their validator operations elsewhere. They funded their subnet design elsewhere, right? So it didn't work. It wasn't great. And then another issue was the buybacks. So we were doing buybacks, and we noticed that people would MEV them. We noticed that people would like not sell, and then over time just the price dips. So you never actually return the value to holders. It doesn't work as well as something like an airdrop did. And this was something that that I was told by one of the TaoHash holders, and he made a really good point about it. Obviously, the currency risk, but that's a smaller problem. And then the redesign, what we did is we decided instead of taking all of the Bitcoin, right, and having this problem of the scale, right, and having to match, because we had to match the amount that we took out, right, that we made the miners produce for us. We had to match at least that, and there's very low margins on that. So it's very hard to match 100% of that all the time and to never have the price dip. So instead, we said, what if we operate like a regular pool? We just give back some of the Bitcoin. We take our pool fee for giving them rewards all the time. And then we're still incentivizing them to be in the pool. We can still use their hash rate and redirect it to sell it. But since we're returning the part of the Bitcoin immediately, we're now lowering the amount we have to incentivize by a huge portion. And then there was, that was basically all. But then there was people saw these issues. They brought up these issues in the channel rather rudely. And we responded and we adjusted, and that's how it goes, right? And that's what we hope to do in the future. So if you have issues with how it's designed, if you have feedback, we love to hear feedback. We live on feedback. Can I show the formula again? Yes, I can show the formula.
Well, there's the original design, like the issue that I had with it was that the original plan for Bittensor was to take the efficiency of Bitcoin and apply it to other things. But in so abstracting the concept of Bitcoin mining, we also make it somewhat less efficient. There's just a lot more fuzzy. There's a lot less consensus. There's all of these like market inefficiencies. Whereas Bitcoin mining, the hash rate market is probably the most efficient market in the world, right? And I think that, and so you guys, the original design was like, okay, we'll pay you for the Bitcoin you can mine, but the cost of that Bitcoin is just about the same amount that you'd have to pay them, if not slightly more. And with the inefficiencies of Bittensor in place, it just creates downward pressure on the price forever, because you're never going to be able to make as much Bitcoin with a less efficient machine. I mean, and there was some margin aspects like 2% here, 2% there, but it was very minimal. But you guys don't have that structure anymore, right? So because you give the Bitcoin back to the miners and you just subsidize, so you're giving the Bitcoin back to the miners, and the alpha, how does the alpha actually play a role here? So like
we do this thing where the validators, they calculate their stake weight. Right now it'd be a rough stake weight because all of this is fairly rough. But when Ref gets his feature in about having the stake weight frozen for the epoch, it'll be much more accurate. But basically, you take your stake weight, you take the alpha price, and you take the tau price, and you multiply them all together, and you can find out roughly how much a weight you give to a miner is probably going to be worth, right? And the rest of it you can burn, so or distribute to other miners. But the rest of it you can burn, right? And then that way we don't over emit value. We can emit not a precise value, but we can emit much lower, and we can emit around the amount we actually want to, which we're targeting right now around 0.5% of the hash rate value. So then miners who are mining get about 0.5% back from the amount that they're mining. And then that way they're incentivized to be registered on Bittensor, and they're incentivized to use their pool. It has a lower pool fee, and then they're incentivized to participate in the system, to take a stake in the pool, etc.
So there's the pool fee, and then so alpha is the subsidy on top of so they take the Bitcoin, they also take some alpha.
Yeah. So it lowers their net pool fee a bit.
Yeah.
And then the target is 1.5 to 1.75% is the net pool fee for them, which is lower than like basically everywhere else. We're looking to switch to this ocean mining, if anyone's heard of the ocean pool, and this lowers the capital cost for giving out the Bitcoin, and basically makes it so you reward whenever you hit a block. But the whole point is mainly doing that hash rate marketplace, because TaoHash is designed after this company called NiceHash, which they financialize Bitcoin hash rate reselling, and they do really well at it. But they were doing better before they had KYC, and through decentralization, the magic of decentralization, we can take back that market share that they lost, and we can open up the ownership of NiceHash to basically everyone. And that's the huge goal. Yes, exactly. Kill your customer. Yeah. So so we're hoping to open that up, and that adds a premium to the hash rate price, right? Which makes you benefit even more than what you're actually incentivizing for. It also means miners can get quicker payouts and lower pool fees.
Take us through the logic of the scaling of the hash rate being effectively infinite here.
Well, it's not effectively infinite. I mean, if price goes up continuously, it's effectively infinite. But this this slide, if you can see it, so we're currently, this is based on our max amount, not the current hash rate we're at. We're far lower right now. But so the current hash rate that we can maximally incentivize at the current price, or at least at $7, is around something like 7% of the current Bitcoin network hash rate. And that would scale linearly because as price increases, you commit more.
Wait, sorry to interrupt. We're 7% of Bitcoin?
No. It's the maximum that we can incentivize. So assuming 100% of the alpha gets emitted to miners, it would be for 7% of the network hash rate. So that's what we can scale up to. So people can deploy. Sorry,
what are we currently?
it's dropped a lot since the changes. I think we're around. Actually, I can check right now. It's live. 24-hour hash rate is about 48 petahash. 1 hour hash rate is about 95, and 5-minute hash rate is about 105 petahash. So it's quite a low percent, but it's not nothing.
So it's under a percent of the network.
It would be 100%, yes.
100%. And can you explain again? Sorry, I interrupted you, but like how this scales better than the previous design? And like,
so the previous design, if we look at the equation. So right now, the miner reward thing is what we're changing. So right now, it's at 0.5% of the value of the hash rate that you're trying to give to them. Right? That's the amount you're giving them in alpha. That's what you're targeting. You're trying to match that at least 100%, right? Because if miners don't break even, they don't want to mine. So you have to at least give them that, right? You have to give them this like some amount to do with that, right? So their theoretical production is hash price of the like Bitcoin network. This is like a hugely like calculated metric. It's available everywhere. It's fairly big consensus on it. So the hash price changes based on like network difficulty. So how likely are to hit a block, what the current like fee rates are on Bitcoin, what the current Bitcoin price is, etc. And so you get a hash price, and that's something like $57 to $58 per petahash a second per day. So that's the amount you could expect to mine, assuming you don't have any issues with the variance of blocks or anything. And that means that per day, if we wanted to incentivize some hash rate based on the petahashes, we would want to incentivize it. If we did 100% reward, like 100% subsidy, we paid for all of the Bitcoin and just took it all, we'd have to do the price times 0.41 times 7,200 blocks a day divided by the hash price, right? And that's very, very low. I could calculate it right now, actually, and then just to give like a illustration of what that is. 0.41 times, say, $7, 7,200 blocks divided by the I think it was, what did I say, $57. That's about 362 petahash. So that's over only 3 times what we're currently at, right? That's not a high ceiling. We were at like 10 exahash at one point when we first launched TaoHash, and we would like to get back to that. So this would be a problem, right? You would need the alpha price to go way up for you to ever get back to that. But if we lower the miner reward part of the equation, if we lower it to a smaller subsidy, and then we end up giving back some of the Bitcoin to also pay for that Bitcoin that's coming to you, as you give some of it back, you only keep the pool fee, which is a standard thing in Bitcoin mining anyway. So you're able to scale much higher by just lowering the amount that you have to pay for, the amount you have to cover.
Okay, makes sense. And Cameron, one more question for me. I don't want to derail the presentation like I do every week. But secondary market for hashes. Where is this secondary market for hashes? I didn't understand. I've never heard of that actually before. Like my understanding was that there was pools, but there's another level to the market, like the.
It's a huge thing. So the NiceHash founder talked about it in an interview. I think there's like different like opinions on why it's great, but it's basically like futures, right? Like hash rate is effectively a future for Bitcoin. There's like a varying like production of it, because the hash rate, like obviously it fluctuates based on your contract. assuming you can hit like a specific quantity of hash rate, and then the difficulty like adjusts, you'll have like a variance in the amount you'll actually produce. But roughly, it's like a futures market, right? And it's also like something you'd want a futures market on top of, right? So you'd wanna somehow hedge your risk as like a mining pool. So you would say like, I don't know how much I'm gonna produce, but I have to pay all the miners who are giving me hash rate because they expect to cover electricity even if I never hit a block. So I need to somehow hedge the block luck, right? Because the blocks don't hit perfectly on the probability of your hash rate as a percent of like the network hash rate. You're not always going to get that amount. On average, you will, right? But on average means very long time spans, right? Might mean forever. Over the course of the Bitcoin network lifetime, you might never hit that average, right? You could be extremely unlucky and then your pool goes bankrupt. So you gotta hedge it some way. So there's futures markets on top of that. People also do it for arbitraging, right? If you were to want to speculate on the Bitcoin price, you could also do it that way. You just buy a hash rate contract at a certain price, and then if Bitcoin price goes up, you made money. But there's tons of markets that do this. There's NiceHash, there's mining rig rentals. I know there's a couple TaoHash competitors popping up on solo chains.
Very cool to see. Where can we find these competitors to TaoHash?
There's one that went bankrupt. I forget the name of it. But it's because they're not designing it well, like we are. And then I forget the names of the other ones, but there's a couple on Twitter. You can like search for it.
Okay, so I'm going to back up and see if there's questions from the chat. I've obviously gotten all of mine in. Are there any questions from the chat from the stage? Rob, Abe, I guess you have questions about what you're building. If not, then perhaps we can go forward. But Rob,
I was just gonna say, I think that it makes a lot of sense. The direction that y'all are taking TaoHash. I'm curious to know if there is an actual market where maybe say like can I buy the right to hash power?
Yeah, So that's what I would be. Yeah, it's like options. You'd be buying the hash rate, and then they would be giving it to you. NiceHash, because it's hard to like get a perfect hash rate like guarantee, right? So what they do is they estimate based on uptime and stuff, and they say like we have a fairly good guarantee of uptime of these miners for roughly this quantity of hash rate. We'll direct that to you for X amount of time, and until like all the amount of like hashes that you paid for, like the volume of hashes, right? Multiply like hash rate by time is like covered, right? So that's something like what we will do. Ours will be like less guaranteed because it's decentralized, but that just goes to the free market on top of it, right? So we would say like we will direct hash rate, all of the hash rate to you, for instance, or some percent, and then all the miners direct their hash rate to whatever person buys it for that bid, and the validators will make sure they do that because they get no incentives otherwise, right? And then otherwise we just have to keep sending to this person until we meet that quota, right? So there's a little bit of risk on the buyer side, and there's like things to figure out there. But for the most part, it'll be a decentralized market where you can pay in Ethereum or Monero or what have you.
Yeah, I'm thinking so. At least on compute, right? This is something that I've also thought about. Where, if you're buying a node for $250 and the price slides to $2, right? You probably want to own a put on that at a strike price of $250 so that you have that downside protection. I'm curious, are y'all going to implement something similar to this with maybe like Bitcoin hash rate? Because I think that this would actually be like, if you look at the insurance market for automobiles, it's about 25% of the market cap of the automobile market. Like the entire if you sum the market caps of the automobile manufacturers, right? The insurance market caps for automobiles comes out to about 25% of that. And so I'm curious, like, does this market exist today where I can buy, like, if I'm a miner and let's say I go and I buy a bunch of hash rate, right? But then let's say there's like a sudden spike, I guess, in that hash rate. is there, I guess you would want to buy a put in that instance because hash rate would decrease your earnings. Am I correct?
Yeah,
in that?
I'm not sure if we could construct a put on it, but yeah, the global hash rate, if it spikes, your earnings decrease unless price spikes like relatively, right?
Interesting.
Yeah,
Very cool.
so because it's like it's fully competitive, right?
Yeah.
It's the same
Very-
thing with mining, like on Bittensor. They don't want to oversubscribe, right? If you oversubscribe, you pay too much electricity for what you're producing. You lower your profitability. But if you undersubscribe, people get more Bitcoin than you.
Interesting.
And then
Interesting.
yeah, I'll read
So
some more
by
questions.
proxy, a way to like probably a financialization on top of the Bitcoin mining market, like the entire market, is probably buying like calls and puts on electricity prices. But I don't even know if that market exists. I'm sure it does though.
Yeah, but that would have to be like global, like average, like electricity prices, right? Or probably weighted because you weight towards the cheaper ones, right?
Look
Yeah,
at these nerds.
it's so cool how Bitcoin makes electricity portable.
Yeah, yeah,
I won't like remiss about this too much. I don't want to derail the conversation, but
yeah.
it's like if you wanted to buy, like, electricity is electricity, but like electricity is kind of localized, right? I can't just go get electricity from Iceland and bring it to my house in Texas, right? And so, but if I mined Bitcoin Iceland, then I could like transfer it to America. It's very interesting. Anyways, please continue. My apologies.
Yes. So someone is asking, how is this different to 89? So 89 is one of the subnets I was speaking of at the start. So they changed. Let me go to the slide where we talked about our problems. So if we show all these problems here, so they changed when they designed it. They only changed problem 3 here of the trust invalidators. So all they suffer from all these other issues. So that's the main difference with them. And then why not make the pool fee 0? Oh, sorry, what?
I was just gonna say that like we don't want to beef on other subnets here
Yeah.
either. Like there's a longer conversation we probably would have to get Ref up on the stage to do it justice. So it's not intending to throw shade as they say. But let's go to the next question. What was the next one?
Totally. Why not make the pool fee 0 until you dominate? Then you can monetize the hash power. You not be limited only mining Bitcoin. That way, I'm sure miners will. So this is something. This is something that that Fish brought up as well. He was saying like, why not make the pool fee low and then use that to market so you get a lot of hash rate. But the problem with that is hash rate is a very elastic market, right? So like the demand is super elastic, or sorry, the supply is super elastic. So they will just move. The miners will just move. If you increase the pool fee, they just move. So it doesn't make sense to subsidize temporarily. You have to pick like a forever rate, and then market, hope people like to get to you. You can't like change it too much.
If it's so elastic, Cameron, then why isn't everybody here mining on TaoHash?
Well, obviously there's obviously like social like layers to this, right? We have to market the product more to more people, get them to see it, because even though it's a great product and it's one of the best products, is you need people to come and they need to see it and they need to realize how good it is. So we need to still market it, but the main thing is we can't make it 0. We do have to pay for the capital cost of the Bitcoin until we switch to Ocean. We have to pay for the inflation that is happening when we send stuff to miners as well.
Right.
Is the hash rate specific to Bitcoin mining can be used to mine another shitcoin? Yeah, it totally could. You could mine any shitcoin. I think that's something that Quant suggested is what if we did like a multi-pool where we like target other coins or whatever's most profitable. But if anyone like is familiar with the mining as a business, that typically doesn't work well. There's a reason Ant Pool is mainly on Bitcoin. They do merge mining, which is something we could start doing. Is the sum of hash rate can be rented and used for buyers' intended purposes? Are there measures in place to prevent the hash rate from being used for nefarious purposes? No, there are no measures. I don't like. I would hope we don't reach over 51%. Because that would be a lot to wield, but it's possible. And I mean, if we do, we can't do anything about it. That's the beauty of decentralization. Subnet, okay, they're just talking about 89. Yeah, that's roughly a good comparison. Any other questions, guys? Lowering the pool fee is marketing. It's some of lowering the pool fee is marketing. But you shouldn't like use it like that much because again, it's like the problem with if you ever heard of it, the Subway footlong $5 footlong problem. So Subway put footlongs at $5 for like forever, and then they tried to bump the price because there's a discount, right? They tried to bump the price back to a normal price, and nobody wants to buy Subway anymore, right? So it is just I think it's overpriced, right? It's you change the perception. It's not great long term, and obviously Subway is much more inelastic of a market. Like people will pay more for subs, but people are always going to switch Bitcoin pools really quickly, right? So if we can get down the cost of the pool fee because we're openly owned, so each individual can stomach different costs for running this infrastructure, right? You don't have to just worry about huge amount of employees, right? We're fully we're open source, right? We don't have to pay all those costs, and we can get that down. Then we can just get all the people because people will come to us, right, for the lower pool fee. Again, we have to market it though. Negative fees. We're not doing negative fees. It's a horrible idea. That's actually negative fees is what it's like Cubic or something is trying to mine the Monero network right now, and they're trying to take over. Yeah, they're trying to take over the Monero network with a 51% attack, and it's a good idea if they can get to it. It's because Monero mining is like famously unprofitable because it's all CPU mining, so anyone can do it. So super efficient, way more efficient than Bitcoin, right? Anyone can do it. But the big problem is it's actually too efficient because people steal electricity and steal compute through botnets and likewise, and they end up having negative profit, and it doesn't matter because they don't pay the expenses. So what this Cubic network did is they were like, what if we issue tokens to the people who mine Monero for us, and we pay them more? We actually fully subsidize. We give a negative fee to them. And the problem with that is it ends up with like the old design of TaoHash, where now you're paying more than you could actually incentivize. And that means people, when they sell your token price will dip and dip and dip unless people keep buying in and subsidizing it, right? So you're creating the spiral downwards unless people keep buying in. Why does 14 feel so strongly against 89? I mean, I don't personally like we said at the start. It's a category defining subnet, right? We were the first to do a subnet like this. There's been at least 2 others. There'll probably be more. Obviously, compute subnets, maybe more broadly, is like the bigger category. But no, I don't harbor ill will. Yeah, what if we just print Bitcoin? Yeah, if you took 51%, because that's what they're doing with the Monero thing. If they get 51%, they're hoping that they can just direct the block rewards fully to themselves because they've hostilely taken over the network, right? They don't have to pay the other 50% of the hash rate. They only need 51. Any coding development needed for providing hash rate or just providing device? Right now, it's just providing the device. We removed the difficulty with who you direct it to and stuff like that, and the need to optimize that. Until we get to saturation, you won't really need to balance it. What would incentivize mining companies to join if they're taking in pool fees too? We don't need mining pool companies to join. We need mining farm companies to join, right? So the mining pools would be our competitors. It's hard to compete with a bunch of different people instead of just one big, a couple of big conglomerates, right? How do you defeat the many? Any more questions before we move on? 14 does not need a chef. That's actually I dislike that idea strongly. I'm not going to say more about that, but I don't like that idea. So no, that's not happening. Okay, we may move on. I'm not seeing. Oh wait, how long till dashboard's live? Dashboard's already live. If you're talking about the alpha holders, we will have to put that up. So Q3 ends at the end of next month, so we will be working on it more and putting it up. Yeah, there's also TaoHash.com. I think is the one that Abe prefers. It's the same one, but it's a nicer URL.
Imagine if there was a .hash TLD.
Yeah, we could buy it.
That would be sick. Tau
Yeah, there's a
.hash.
.zip.
Tau.app, Tau.hash,
Hash.tab.
Tau.money.
We're not planning to do buybacks and burning anymore because we won't be earning as a validator. We won't be earning any of the Bitcoin ourselves. It'll all be going to holders. They won't receive Bitcoin for a month. Well, we don't throw out the Bitcoin that goes to the balance from the pool when we don't distribute it. Boon.hash, yes. Why is it so volatile? It's so volatile because people have different there's different competitors in the subnet space, and people have different understandings of it. Right? It's an asymmetric market. You'll notice a problem when if you overpay for hash rate, you'll get people doing arbitrage through stuff like buying on nice hash and mining rig rentals, which are secondary markets that already take a margin. So you're basically just wasting money at that point. So something that happened when the reason we dipped a lot after we changed some of the design is it was no longer profitable for people to do arbitrage on in that capacity. So it dipped a lot because of that. You can still do it a bit because the pool fee is lower, probably, but you'd have to be very careful about it, or you'd have to steal someone's Bitcoin to pay for it. Bitcast campaign. I'd have to check out the Bitcast subnet more and see what's up about that. You should keep asymmetry. No. Okay. We will continue with our presentation then. Almost done. Hang in there. Does everyone see that still? Yes? Okay, nice. Subnet 5.
Yo.
It's a collaboration time. Do you want the floor, Kara?
Sure. I mean, thank you. Well, yes. So we are collaborating with Latent Holdings on Subnet 5 to do hierarchical AI pre-training. I'm going to drop a link in here right after this, which is going to be kind of a refresher for people who are unfamiliar with hierarchical training, why we need it, these sorts of things. Our main goal is to solve ArcAGI2, I would say in this exact moment. And so our mission is to pioneer a new path to AGI by harnessing hierarchical learning and reasoning through an open and decentralized collaboration. We believe that achieving human-level intelligence will not come from sheer scale alone, but from architectures that learn and think in levels, much like the human brain. This project aims to bring together researchers and enthusiasts globally to develop an AI system that learns a world model and reasons abstractly to tackle the hardest open benchmark, ArcAGI2, where current models stagnate at around 5% accuracy. By combining the strengths and approaches like Yan LeCun's JEPA/HJEPA for self-supervised world modeling, and with innovations like the hierarchical reasoning model from Guan Wang et al., which just came out like a week or two ago, for more efficient latent reasoning, latent shout out there, we will create a system that can adapt to new tasks, plan solutions, and interpret symbols with human-like flexibility. Our decentralized pre-training effort means that no single entity owns or controls the resulting AGI. Instead, the project will use open source principles and distributed computing contributions to train the models, ensuring transparency and broad participation. We set out to achieve what was once thought impossible, an AI that can learn from minimal examples and solve novel reasoning problems efficiently, ultimately reaching and surpassing the 85% accuracy threshold on the ArcAGI2 benchmark, a feat that would signify a major leap toward genuine general intelligence. This mission is visionary yet tangible. By focusing on a concrete benchmark and leveraging hierarchical methods, we will drive AI research forward while adhering to the principles of openness and collective innovation. In sum, our project exists to guide open source AGI research towards machines that can learn, reason, and plan as humans do. And in doing so, close the easy for humans, hard for machines gap. Together, the community will build an AI that not only excels at ArcAGI 2, but also lays the groundwork for safe, broadly beneficial artificial general intelligence. So I'm going to drop a link here. You guys can check it out, read it. It's going to give you a broad overview of JEPA, hierarchical reasoning models, the ArcAGI benchmark, and what our vision is. We're really excited to be working on this with Latent Holdings. Feel very honored and blessed to have such a great partner in JJ and Voon. And together we're really gonna try to nail something that I think is gonna push the entire industry forward. Instead of getting these incremental improvements like we're seeing with Claude 4.4 to Claude 4.1, GPT 4.5 to GPT 5, we're actually going to be able to get a real step function in AI. This is our ambition, and there's a very clear benchmark for us to excel at, which is ArcAGI 2. Yeah, go ahead.
I just want to step in here, guys, and to anybody who knows Rob, knows that he's been talking about JEPA for way too long, way before JEPA was cool. But now JEPA's cool, and especially hierarchical training like this which is I think, as I understand it, it's very similar to JEPA. Has become very cool. This paper that dropped the other day. Who dropped it? What was this team?
I believe it was. I had it just Sapient Inc.
Yeah, and you've been talking about this forever, and so this just shows you how ahead of the curve Rob almost always is. So I mean that's just one comment, but okay, let's get down to so how does the subnet work? What is Hone? What does that mean? What is that? It's an acronym for something?
We're trying to hone in on AGI.
Okay. Okay. It's a cool name. And so what is the subnet actually doing? So okay, we're trying to train models like this. Okay, I understand.
Yes.
But how? Is it a training subnet? We're passing gradients around, we have a state, it's like Templar, like FSDP, Torch Titan, S3 buckets, Hippias. What's going on?
Yeah, so we're going to be doing something very similar to what you were describing just recently. But one of the real benefits to hierarchical models is that we don't need to scale to hundreds of billions of parameters. See, the issue with autoregressive decoders, and I outline this in this blog here, is that essentially purely autoregressive training is sample inefficient. These models need to see enormous data sets of text, yet still struggle with factual consistency and common sense understanding. So a really great example of what I'm talking about, and I'm sure everyone on this call who's ever used any reasoning model that's like Claude, like DeepSeek, like these models, there are thousands of forward passes that must occur in just terms of reasoning traces, right? What's really interesting and great about hierarchical models is that you only do a single forward pass and you have your entire action plan. And so you can plan everything and do everything in a single forward pass. And then what you would do is you would take an off-the-shelf decoder that, I mean, they're a dime a dozen, right? I think how many large open source models came out? There was open source OSS that just came out. There was Kimi K2. There was GLM. Am I missing any? I think that was just like the last week that these models just came out, right? There is no shortage of very large, over 100 billion hyperparameter open source LLMs. Don't buy, don't stake. But yeah, don't stake. Because there's still, this is obviously still something that we want to be able to continue, working on this. I understand, it's great to see that people are excited about it, but so we don't need to train very, very large models for hierarchical pre-training. We can train a 1 to 10 billion hyperparameter model, and the output of that hierarchical model goes into a decoder. So we're going to fine tune a decoder based off these representations that come out of a hierarchical model. And that's actually how we're going to decode it into the particular modality that we're looking for. That might seem complex, but actually I'm going to drop a blog post right here for all the lovers of.
What are miners doing? What are miners doing? They producing gradients?
Yes, miners are producing gradients.
They're sharing gradients, all reduced style.
Yes.
And there's a parameter server.
Precisely.
Is it a similar?
Like, it's gonna take the shape of dloco. There was a paper that came out very recently, like dloco X, right? That's like, we can scale to 100 billion parameters. Maybe you can, maybe you can't. There's like very interesting things like what Macrocosmos is working on with like pipeline parallelism. We can incorporate all of these strategies, but the difference here is that we're not trying to create very large models. What we're trying to create is a hierarchical model that is capable of achieving a very high score on a particular benchmark, which is ArcAGI2.
And so, Rob, when it comes down to like the nitty gritty of the validation system that you're designing here, is it deterministic verification? You say, hey, produce a gradient on this data. The model, the miners produces that gradient, and then that's aggregated and checked by the validator. Are you using a Templar structure where they're measuring the reduction in loss on the batch relative to the larger batch? What's your plan here for that type of architecture around the incentivization?
So we've been implementing. It will probably take a very similar shape to Templar, but I would say that the missions are very different. So I'm hesitant to put the word Templar out there as a result of that. Yet the work that they have done is really incredible. Evan, Distributed, I mean, love those guys. So it will take and we'll have a lot more of this information coming out in the next week or two with the GitHub and everything. And so I don't want to give away too many details yet, just because we're still in the testing phases with the code. It is taking a very similar shape to Templar, where we are measuring the reduction of the loss. But I do want to be clear on this call that it is not our ambition to, the model that Templar produces is a model that can work in conjunction with the model that's being produced on Subnet 5. Any autoregressive decoder model that is being trained can be used in conjunction with this hierarchical network. So
you can fine tune the model that's generated off Templar. Is that correct, or it's like an adapt?
Yeah. So what how it would probably work? And I was pulling up a. Okay. So here's a really, really good blog post about one of the very first versions of JEPA that Facebook trained, right? Also, I think, and this is just speculation here, but something I find really, I find to be true. I think a large reason around why Meta has recently, dedicated $50 billion, $100 billion. I mean, it's an astronomical sum of money to this, what they're calling an AI superintelligence team, is because they have a real lead when it comes to hierarchical models. And so I think that they've already had internal breakthroughs around this type of model. And so they've seen a lot of promising results, like the one I've just posted here from Meta. This is one of the very early versions of JEPA. I think it came out in 2023? Yeah, June 13th, 2023. So this is a couple years ago. And what they did is they made a vision JEPA where you input you input an image, and it goes in with patches. If anyone's familiar with how image training works and computer vision works, you have these patches. What you do is you remove some of those patches, and then what the JEPA model does is it produces an abstract representation of what the model thinks should go in that missing patch. And so then you can take that abstract representation and train a decoder based off those abstract representations to, say, generate what should go in there, kind of fill in the blank style. BERT's, for those who know what BERT is, mass language modeling, very similar setup in this particular blog post from Facebook. And so I'll actually just screenshot it for those so I can be a little bit more clear. So they removed these patches in this picture I've just put in the chat here. They removed this patch from the image, had JEPA produce an abstract representation of what the model thinks should go there, and then trained a decoder to interpret the abstract representations to generate back into an image. And so you can see that with high fidelity, and these are very small models. I mean, very, very small models. And also very early research on JEPA. It demonstrates the sample efficiency of these models. It demonstrates that, maybe size isn't everything. Maybe it's the way you use the size, as I'm sure many people on this call have heard that before. And so this is really what we're trying to go after. And we have a very narrow scope that we're trying to hit first, which is solving ArcAGI2. For those who are unaware, there is a grand prize for ArcAGI2. And it's a there's I believe it's $750,000. If anyone knows, correct me if I'm wrong. And it needs to be an open source model in order to qualify for this ArcAGI2. They're already in progress on ArcAGI 3, but that data set has not been released yet. Something else that's really interesting that came out of the Sapient lab, that was that hierarchical reasoning model. They actually, it's set up differently than JEPA, but it's the same sort of concept between HJEPA that's described in the 2022 paper from Yanli Kuhn. And I will say that if you go read the autonomous machine intelligence paper from Yanli Kuhn in 2022, it is quite hand-wavy. It's highly conceptual. However, I think there's a lot of wisdom. I think that Yanli Kuhn is thinking about it in the correct way. And we can see that furthered by what Sapient just released with these hierarchical models, where you have a sort of slow method and a fast method. And what's really cool about that is that you need a single forward pass. Now, with a 27 million hyperparameter model, that's something that can run on your phone. That's something that could run on a laptop from 10 years ago. With a sized model like that, they were able to achieve a 6% accuracy on ArcAGI2. Now, I do want to add a caveat here, because there was some confusion when the model came out, that there is, as a part of the ArcAGI eval set, there is an eval train set, and people thought that they were training on the test set, but it's actually like a part of what you're supposed to train on. And they were able to achieve a 6% score on ArcAGI2 with a 27 million parameter model and only 1,000 examples. This demonstrates the sample efficiency, a proof of concept of the sample efficiency and the sizes required to actually achieve something that's better than these 100 billion parameter models. It's truly incredible. And so I would say that a lot of whether it's in the open source AI space that we see with Kimi, that we see with DeepSeek, all the way to what we see here in Bittensor as well with Templar and Macrocosmos, and I think there's a couple others. One, I think, what was it, Subnet 38, Jake? Am I wrong? There's a distributed training subnet.
Yeah, I forget the number. 38. Yes, sounds right.
And so we can use the models that are being trained on there as our decoders for our hierarchical model, and it would actually be very cool when we do the submission. Because there is a compute cost to this as well, this competition. So it has to be very cheap. You can't just like brute force it with an OpenAI model, right? Nor would an OpenAI model, unless it was the open source model that just came out, would qualify for that. So, and all the Anthropic models, OpenAI models, GPT-5, these won't qualify for ArcAGI2, nor do they score very well on it. And it's because, and if I would actually like to show something on the ArcAGI2. This is from the blog post, and I'm actually going to put this in here as well in case anyone wants to read about it. But it's supposed to be very simple for us, like for humans to look at this and determine what the global rule set will be. And yet current autoregressive decoders have real trouble determining what those global rules are. And so we believe that with a multimodality hierarchical model outputting abstract representations that are then decoded into a particular modality that is needed by the ArcAGI2 benchmark in competition. By winning this competition, we're going to be able to lay the groundwork for a much larger model that can really be a step function in the AI space. And it's something that not a lot of people are working on right now. I would say that Meta is probably the only big lab working on it. There's Sapient, which is making good headwinds here. And so I really think that this novel innovation can come from the Bittensor community, where Bittensor is making state-of-the-art contributions, not repeating the paths and walking down the path of where frontier labs have been maybe a year ago, 2 years ago, but somewhere where no frontier lab has really published anything outside of some very cool toy models and some nice blogs and some nice papers. We're talking about something that we can get into the hands of everyday people, powered by Bittensor, trained on Bittensor, completely end-to-end, done by this network. I think that this is something that is really beneficial for not just the network, but for the greater AI space as well. And so we're really excited about this partnership, and we're going to have a lot more information coming soon. The GitHub repo will have a sort of testnet running. Another goal of mine is to start very small, so that the competition itself, when it comes to competing, is not so expensive. So researchers who are on a 40-90 budget or a 30-90 budget can still participate in a system like this. I think that something I've been working a lot on, at least on Subnet 4 with Targon, is our networking capabilities. Determine, you're really trying to go do data center to data center training, which we've successfully done. So there's a lot of code that I've taken from there, which is a part of our strategic business interests with Targon, that we're going to be open sourcing here over on Subnet 5, for lower bandwidth communication. And what's great is that we, because the models that we're training are not so big in the first place, and yet incredibly powerful when coupled with decoders, or just on their own. I mean, is something that I am really excited about is the applications for robotics. This is something that's really near and dear to my heart. As Jake, I'm sure you know, we have Bender here in the office. This is a model that we'll be creating a world model that can then condition decoders that output torque actuations, for example. And so we can have a completely end-to-end system that runs locally on the robot, allowing it not a dumb physics model like you see with the Unitree videos, okay? I mean, you look at these videos and you say, okay, it's really impressive, but these are just physics models from Mujoka. This is not something where I can tell it, hey, go get me a leisure hydration out of the fridge. And this is something that would have to be handcrafted, and this is going to solve a lot of really big issues in AI right now, and I'm really excited about it. So I appreciate everyone allowing me to monologue here, thank you.
Great monologue. This is super exciting. I just want to say, like, one of the most amazing things about the way in which Bittensor moves is that we're always capturing the movement in AI. Like, we're always right there. And like hierarchical models
are really exciting. And this is going to be smaller models, right, Cameron? And who at Rob? So like, who's actually running the subnet? Is it Latent Manifold together? Like, but which part of the team? Like, what can we know about this?
Yeah, so
Deal.
this is a real partnership in every sense of the word. We're contributing resources. Latent is contributing resources. We're going to be working on this together as a joint venture. And so, there's in terms of the mechanics of the deal, I'll be honest. I mean, it's been quite hand wavy, at least from it's just kind of like vibe coded. In a way where it's just like, oh, let's I came to JJ, I said, oh man, I have this real idea, you know how much I love JEPA. I've been having some real problems because you can't register subnets right now, and every subnet person wants like $1 billion in $10. I got quoted $100 million. I mean, it was crazy what these prices were, and so I went to JJ and I said, JJ, I would really love to do this idea. This is a real problem. And JJ said, you know what, I'd love to work on this with you because this is something that's really near and dear to my heart. And so, we're really excited about this partnership. And, also you got to say, I mean, Subnet 4, Subnet 5, I mean, it's a kind of a match made in heaven, wouldn't you say?
Yes, for sure. And so compute on Subnet 4 will obviously, it'll be possible to mine Subnet 5 with compute on Subnet 4.
Of course. And in fact, with our 7.0 update that's coming out next week, we've been doing a lot of testing. This enables a heterogeneous amount of compute onto the subnet. We'll be able to support CPU servers. We'll be able to support GPU servers. We'll be able to support pretty much any type of compute you can imagine on the subnet. And it'll also be a part of our rollout for our programmability layer for the Targon SDK, to where we can create essentially an AI model factory that not only is just supporting Subnet 5 and our open source efforts, to push the limits of where AI is today, but also for the enterprise customers that we're currently supporting on Subnet 4, allowing them to have that programmability layer to plug into their own applications, to be able to A/B test, to be able to measure analytics. Like, okay, this model that was fine-tuned for me 5 minutes ago got me a 3% increase in user engagement. And so, there's a lot of updates coming on Subnet 4 that we're really excited to share over the next coming weeks. And a lot of this has been in support, not just for our enterprise clients, but also for Subnet 5. Now, it's not going to be exclusively Subnet 4 compute. I want to be clear about that, right? It's bring your own compute for sure. Now, one of the things that's really important to me as someone who's mined some of these other training subnets is observability, knowing why, maybe not having to go to a 1DB, for example, to determine why am I losing? Why am I winning? Right? Oh, why is my sync score not working? Oh, this is something that I want to have a robust tooling for the miners so that we can really get a lot of efficiency out of these contributors. And I want to make sure that it's not winner take all, and that that it doesn't get eaten by a single group. I really want this to be something where, with your computer at home, you can reliably train and participate on Subnet 5. Now, you'll have to know how to open ports, for example, if you have a residential internet connection, but still, I mean, that's kind of the idea that we're going for here. An open source, full collaboration
Because the models are smaller, does that mean that you can have multiple training runs at the same time?
Oh, certainly. But I will say, for us, we have a real objective here. And that objective is getting the prize money for ARC AGI 2. So,
Yeah.
We want to win. We're not here, very hand wavy saying, oh, we're here trying to contribute to open source AI. I'm saying that in a very discrete, definitive, measurable way, we're going to be contributing to open source AI by solving the ARC AGI 2 benchmark, which no one has solved yet.
And you have a very clear mission, and so the models are small. They're also sample efficient. So is compute the commodity that a subnet like this is focusing on, or is it something else? Is it more like the ability to like the fine tuning hyperparameters? Like how big are these models? Like, can you give us an understanding of how long it takes to train one of these models that supposedly could beat RKGI?
So we're talking about rapid innovation. We're talking about something that we can go 0 to 1 very quickly. Because, for example, you could train what came out of the paper from Sapient very recently. You could train that on H100, H200 very, very, very quickly. You know, you could be doing batch sizes of 256, 512. I mean, we're talking about incredibly large batch sizes, so we can train rapidly, right? And because we're solving this benchmark, we can immediately have feedback from the road. Like you're driving a car, you're in a race car, a cup car, and you hit a bump, you hit a rock, and you feel that immediately. You have that responsiveness, right? And so by going after a very narrow and discrete problem like solving ArcAGI2, we can rapidly innovate and iterate on the models that we're producing and the intelligence that's being produced on the subnet.
Very cool. And but Rob, if the model can be trained so quickly and on a single H100, what's the purpose of doing a distributed training network? I mean, I guess maybe like this is more of the details of the specific subnet, but pre-training subnet like Templar or IOTA, they're specifically designed to hit extremely large parameter counts, and that's why they need to aggregate compute from a set of different data centers and providers and contributors. But is that really the dimension that needs to be optimized with something like small models like this?
So what I would say is that, yes, those subnets are designed to scale, but that scale comes at a cost. And that cost is bared by the participants, the alpha holders in that subnet. What we want to be doing here is we want to be very grounded. And we want to be rapidly iterating on this benchmark. And so what that means is that, yes, while the models are small, that what we can do is we can recursively optimize using the power that we've all seen here from subnets in Bittensor, how powerful they are at reducing the cost. I mean, I was looking at my subnet today, $1.34 for H200s. I mean, you can't beat these prices. You try to go get your own contract today, you're going to be paying $250, $240. I mean, you're going to be, maybe it's at $2 now. I don't know. I mean, I haven't talked to one of these brokers in a minute, but I'm just saying that, like, that is what Bittensor is really good at. And so the objective is, while we are training models, right, really our objective is to solve ArcAGI in the cheapest way possible, because this is a requirement from ArcAGI2. We have a limited compute budget that when they run the evals on they download the model and then they run the evals, we have a limited compute budget on what we can operate on. So this adds a cost function very similar to how there is with DTAO, there was a cost function implemented, in RootNet in pre-DTAO times. There was only a reward mechanism, right? So we're talking about like RL Gym, like 2016, OpenAI Gym when it's only a reward model, right? Now we're adding a cost function, with DTAO. And so as a result of that, right, I mean, if we're training very small models using inexpensive hardware and yet beating the state of the art, I mean, this is something that really could only be done on Bittensor by leveraging the power of subnets themselves, by leveraging the power of an incentive mechanism. And so this is something that we're really, really, not just excited about I'm personally excited about because I'm fulfilling a lifelong dream of mine, right? But also, this is something that we know that we can train these models and achieve our discrete objective, which is the ArcAGI2 benchmark and receiving that prize money, which is it's a pretty sizable amount of money. I think it's like $750,000. I mean, we're talking about, that's a lot of money. And that's something that we can win, especially if we only have to spend a very very small amount on the actual compute itself. And so obviously the size of these models, like I said earlier, will probably start out in the 50 to 100 million range. We'll scale that up probably to 1 to 10 billion. We will conduct a lot of research. This will be an AI model factory, guys. I mean, we're talking about something that is constantly, iteratively, and recursively improving to solve one problem, which is the ArcAGI2 benchmark. And then we'll use those models in a variety of ways once we produce them to do, coding and robotics and these other things on top of that, right? But by having something that really grounds us, which is that benchmark, we're going to be able to rapidly iterate in a way that we can show meaningful improvements in not just this very narrow kind of very narrow like range, which is like hierarchical AI models. But also we'll be able to do it in a way that does not destroy the alpha price.
Right. It sounds like there's a lot of opportunity here, like with small models and a clear goal, and especially with the power of Bittensor to optimize things like how this subnet's can be built. Like, what's the timeline for the actual release?
So I want to do it quicker than 2 weeks. I want to say publicly 2 weeks because I don't want to box myself into a corner. I don't want to make my guys, yelling at me saying, I don't want to work the weekends, this sort of thing, right? But I want to commit to 2 weeks, right? We will start the AI factory. Maybe that would have been a better name now that I think about it. We just call it AI factory. But so I want to say 2 weeks. It might happen quicker than 2 weeks. If you're interested in participating in this subnet, if you're interested in pushing the limits of where we are today on open source, AI and AI in general, I think Subnet 5 is the place for you. If you don't have $50,000, $100,000 to be able to rent a cluster on H200s to train a very large model, this subnet's probably for you. And so we're because we have to do this in a very affordable way, not just because we have multiple cost functions. We have the cost function of the alpha price. We have the cost function of the ArcAGI2 benchmark. So we are really kind of, we're really kind of fenced in what we can do. It's like, like in Formula One, right? You have Mercedes who can spend, $1 billion on their Formula One team, and you have a team like Haas who couldn't spend $1 billion, has probably never seen $1 billion. And so, you have to implement these price caps in order to make the competition competitive, right? That's the same thing that they've done on ArcAGI2. And so I think that this is really a way, like, to push the entire industry forward in a way that doesn't break the bank. And so this is, something that we're really excited about. And thank you.
Thank you, guys. This was a real pleasure. We lost Joseph, but we still have Abe and Cameron. Anything else we should do?
Nope. Thanks for having us.
Yeah.
Like, this was a huge success.
Amazing, guys. Thank you so much. All right,
Maybe we should do a Bittensor on 3.
let's do a Bittensor on 3.
Okay. All right. Bittensor on 3. 1, 2, 3. Bittensor!
Bittensor!
Thank y'all.
Yo, thank you, everyone. Thank you guys so much. All right. I'll see all of y'all later. God bless you all, and God bless America. All right.
Ciao.
Thank you. Ciao.